Okay, let's unpack this. Today's deep dive is into a really classic tool for visualizing relationships. Information, really.
A visual tool.
Yeah, and we've got sources covering, the basics of how this works, but also some, well, surprisingly powerful ways it can help clarify things, solve problems even.
It's pretty neat how simple it seems, but how much it can do.
Right. So the mission today, show you how a few simple shapes can make some tricky connections, well, instantly clearer.
And it all goes back to John Venn, an English mathematician. It's his concept, fundamentally.
Absolutely. So what do we talk about exactly? Our sources lay it out pretty clearly. They're basically drawings, pictorial representations of groups or sets.
Right. You start with a big rectangle, usually. That's your universe for whatever you're looking at, everything you're considering.
Sometimes labeled with a Greek letter, T, or just U.
Yeah, exactly. And inside that box, you draw circles or ovals. Each circle is a collection of things. Items, people, ideas, whatever shares a characteristic.
Okay, simple enough. But here's where it gets really interesting, isn't it? These aren't just static pictures. They actually show you how sets relate.
That's the key, the visual relationships. Our sources show this clearly if the circles don't touch.
Totally separate groups. Disjoint, they call it. Nothing in common.
Bingo. And if they overlap?
That's where they share things. That middle bit, the overlap, shows the common elements. Joint sets.
And there's one more main type if one circle is completely inside another.
Like all squares or rectangles, that kind of thing.
Exactly. One set is a subset of the other. It's all contained within it. The diagram just makes these relationships pop. You see it immediately.
Okay, so you can see the relationships. But how does that help us, do things with the information? Combine groups or compare them?
Well, that brings us to set operations. And again, the diagrams make this stuff much more intuitive. Let's say you want to see everything that's in either set A or set B, or maybe in both.
Like merging two playlists.
Kind of, yeah. That's the union. And visually, you just shade in everything covered by both circles, the whole area.
Okay, and what if you only want the stuff they have in common, just the overlap?
That's the intersection. And you just shade that specific overlapping region. Simple as that.
Right.
And the sources show you can do more, like visualize the difference, everything in A that isn't in B. Or even shade everything outside a particular area, like the complement. It's all about shading the right region.
So what you mentioned sources showing this.
Yeah.
Can you actually use these drawings to, prove things?
Yeah.
Logically?
You absolutely can. It's actually a neat way to verify set identities. You know, those equations like A cap B, A cup B.
Okay.
You can draw the diagram, shade the region representing the left side of the equation, then do the same for the right side on a separate diagram if the final shaded areas look identical.
The statement must be true. Wow, okay, a visual proof. That's pretty cool. It forces the logic.
Kind of, yeah. The visual consistency reflects the logical consistency.
But this isn't just for abstract logic, is it? Connecting this to the bigger picture. Where does this become, practically useful day to day?
Oh, hugely useful. Especially when you start putting numbers into the regions. Think about survey results.
Okay.
Imagine you ask 100 people about two products, A and B. Maybe 60 like A, 50 like B, and 20 like both. Now, how many only like A? Or how many like neither?
Right. That sounds like it could get confusing just looking at lists of numbers. A bit of a headache.
Exactly.
Yeah.
But with the diagram, draw your two overlapping circles, A and B, inside the box of 100 people. The key is usually to start with the overlap. How many like both?
20.
Right. So you put 20 right in that overlapping section. Now, we know 60 total like product A, but 20 of those are already accounted for in the overlap.
So you subtract. 60 minus 20 is 40. Those 40 only like A.
Precisely. Put 40 in the part of circle A that doesn't overlap. Now do the same for B. 50 total like B.
Minus the 20 in the middle.
Yeah.
Leaves 30 who only like B.
You got it. So now in your circles you have 40 only A, 20 both, and 30 only B. Add those up.
40 plus 20 plus 30? That's 90 people inside the circle somewhere.
Yep. And since we started with 100 people total.
100 minus 90 is 10. So 10 people must be outside the circles. They're like neither A nor B.
See, the diagram organizes the numbers visually. It makes the calculations almost obvious. Those formulas you sometimes see, like for the union, they're just describing what the picture shows.
That makes so much sense. So really, what this means for you, listening, in a world just swimming in data overlapping categories, being able to see these connections, it's like a superpower.
It cuts through complexity.
Yeah. Whether you're, organizing research notes, trying to understand market segments, figuring out teen skills, Even just sorting your own thoughts, sketching a quick diagram can just clarify things instantly, reveal connections.
It transforms that jumble of information into something, well, into a map you can actually read, an intuitive visual.
So we've seen how this incredibly simple visual tool, centuries old, clarifies relationships, makes logic visible, even helps solve numerical problems.
It really is quite versatile.
It really is.
Yeah.
And it makes you wonder, doesn't it? If visualizing things this way unlocks so much, how else could mapping out the overlapping sets in your own life, maybe your work, your projects, your studies, how could that reveal connections or insights you haven't even considered yet?